PEXIS is an European research project funded by the Fuel Cells and Hydrogen II joint undertaking, aimed at demonstrating a system for green hydrogen generation, that is, hydrogen formed by solar-driven electrochemical water splitting. In the framework of the project we have realized a demonstrator for direct conversion of solar energy to green hydrogen. This has been realized through the collaboration of Italian National Research Council with the Forschungszentrum in Jülich, and Enel Green Power here in Catania. The photovoltaic effect is the generation of voltage and electric current in a material upon exposure to light. The active heart of a photovoltaic cell is made of two thin regions, one above the other, each with specially added impurities called dopants. One region is of type N, with an excess of electrons negative, while the other is of type P, with an excess of positive holes. In between the two regions an electric field is produced. In particular, a silicon heterojunction bifacial solar cells can harvest light, from both top and bottom side, of the cell, achieving high performance in terms of power output. When photons arrive into N-type region create free electrons and holes. The internal electric field and carrier concentration gradient makes them move in opposite directions, the electrons move towards the side N and the holes move towards the side P. An electromotive force is generated between the P and N regions, with P positive and N negative. Using wires, the side P and N are connected to a load, such as an electrolyzer, and electric current run through the load. The electrolyzer is an electrochemical system where the reaction of water splitting takes place. In particular, electrolysis is the process of using electricity to split water into hydrogen and oxygen. Water electrolysis is a promising option for hydrogen production from renewable resource. The demonstrator system consists of a photovoltaic mini-module with three silicon heterojunction bifacial solar cells directly coupled with a proton exchange membrane electrolyzer, so-called PEM. The optimal coupling, of high-performance silicon heterojunction solar cells, with high bifaciality coefficient and a high-performance PEM electrolyzer, allows to reach very high solar to hydrogen conversion efficiency. The sun through electricity generated in the solar cell will split the water molecule present in the PEM electrolyzer in H+ and O2 ions. Then they are separated by the membrane and then sent to the cathode and the anode, where are converted in hydrogen and oxygen molecules. The demonstrator has been recently installed for outdoor operation in Catania, and it is now operating continuously from about 1 month, so far with no apparent degradation. The system produces green hydrogen with remarkable performances. The solar to hydrogen efficiency varies mainly with the solar irradiation level. Conversion efficiencies up to 15.5 are observed. Moreover, the peak hydrogen gas flux reaches the level of about 3.2 grams per hour and square meter of photovoltaic module. For more information please have a look to the PEXIS project website.